Okay. So, this process here, we will refer to that as the dissociation of an acid. In water. Okay? This is the dissociation of acid in water. With H3O plus and A minus. Yes?
Is that red for a reason?
For emphasis.
Oh, but not necessarily.
It's not a box, but it's something that you ought to be able to recognize. Yes?
And A minus is just like any element.
Any anion.
A minus is unacceptable.
It's a slap in the face.
Slap in
It is.
In fact, maybe we ought to make that distinction here.
You're almost smart enough.
Now, do you remember last year when we talked about the anion associated with the acid? Do you remember why the anion was important? Why we had to know the identity of that anion? To name it, yes. All acids produce this, so that's not really the distinguishing feature. You know, what's the difference between hydrochloric and nitric? This is. The anion ends up being important. Now, for most of our conversation in this chapter, we're going to focus on the H+. Towards the end of the chapter, though, we're going to take a look at the anion and find out that sometimes that ends up being important too. Okay? All right. Let me take a peek here just a little bit. All right. So, I wanted to show you one other thing here. This is a dissociation reaction, but we can also treat it as an acid-base reaction of its own. Okay? So, what we have here, let's see if maybe I can move the red down just a bit. Will it let me? Oh, hot dog. All right. So, this right here is an acid. Okay? That's the generic form of an acid. Now, what do acids react with? Well, lots of different things, but primarily bases. Is water a base? Is water a base? Let's go back and look at our definition.
Yes.
Can water accept a proton?
Yes.
How do you know? Because it just did it. Okay? So, in this case, we consider water to be the base. Now, when this happens, the acid and the base make a couple of products. If you take the base, and I always have to be very careful when I do this, okay? You take the base and you add the proton to it. Now it has a proton that it could give away. So this, once you add the proton to it, now becomes an acid. Specifically, we refer to this as the conjugate acid. Okay? And then the anion that's left over is now capable of accepting a proton. And accepting a proton means that it's a base. This is now the conjugate base. Okay? This is a part that people frequently get confused about. So the next slide we're going to do is we're going to work up some operational definitions. Working definitions of what is an acid, what is a base, what is a conjugate. Okay? So everybody got what you need from this page? All right. Let's write some definitions then. An acid. What is our definition of an acid? According to Messrs. Bronsted and Lowry.
Proton.
Gives up a proton. So acid gives up H+. If you're trying to identify in a chemical equation, an acid-base equation, what the acid is, it's whatever gives up or loses H+. Okay? What is the base then? It's whatever receives or accepts H+. Okay? Those two are fairly straightforward. Now let's talk about the other two. What is the conjugate acid? Well, the conjugate acid is the base after it has received H+. Okay. The base after it has received H+
That's the conjugate acid.
is the conjugate acid. I know, it's a little confusing. What is the conjugate base then? It's what remains of the acid after losing the proton. Now I want you to begin to get into the habit, when you look at acid-base reactions, before you start doing anything, identify, this is the acid, this is the base, this is the conjugate base, this is the conjugate acid. Okay? Sorry, kind of in the way. Wouldn't be the first time, I suppose. All right, are you fairly comfortable with this? It's some new terminology. It's going to take some getting used to. But learn these four definitions. Okay?
Will it be like a multiple choice question?
It could be. It could be. What you could see, for example, is a reaction, and it says which is the conjugate base. This, or this.
Pretty amazing.
What's that?
Rank up the points on that.
You could. Mm-hmm. All right. Next thing. We need to talk now about strong acids and weak acids. Okay? We'll go back to our dissociation reaction here. Okay? Now, the fact that we've drawn the double-headed arrow there probably puts you in mind of what? Equilibrium. Okay? So, a strong acid, how would we define a strong acid in terms of equilibrium? Well, let's go back to talking about electrolytes. What is an electrolyte?